We are in Advanced Math Trig, mods 2, 3, 4, and 7. Today is Thursday, May 14th, so top left corner of your notes, 5-14-20. Again, progressing through our outline or our library of functions. We are on reciprocal functions. A reciprocal function is kind of just what it sounds like. Instead of y equals and having some x's or x squareds involved in some normal typical function, that function has been reciprocated and flipped over so that the x or x's are now on the bottom. So as soon as you see 3 over x, or in this case, negative 2 over x plus 1, or even negative 1 over x squared minus 4, and you're noticing, oh my gosh, there's a variable on the bottom. What has to jump into your mind is a vertical asymptote somewhere, right? Because remember, when the bottom of a fraction is a 0, that's undefined and doesn't exist, which is where you draw an asymptote on your picture. So procedurally, if you're, again, trying to do this quickly and accurately, the second that you're sketching a function and you see a function that has an x on the bottom, you are making a table, you're drawing or sketching a picture, and how do you know what number to plug into this table? You don't, again, just plug in negative 2, negative 1, 0, 1, and 2. As an automatic reflex. These aren't linear functions. There's something special. They're reciprocal functions. So you actually want to plug in whatever number causes the denominator to turn into a 0. So in this first case, of course, what number would you put in for x that would cause the bottom to become a 0? Well, of course it would be just 0, right? And 3 over 0 is undefined. And even though that doesn't exist, that's important because that tells you the location of your imaginary vertical asymptote or wall that you've got to create as a starting point on your picture. Okay? So I'm going to draw a vertical asymptote right through 0. And all you got to do is draw some kind of a shape to the right and then some kind of a shape to the left. Okay? Now, just to get that shape going, if you picked a couple of numbers to the right, like 1 and 2, obviously 3 over 1 is 3. This is not difficult. It's quickly done. Plug 2 in for x. 3 over 2 is, what, 1.5. So obviously, to the right of my asymptote, I'm going to go right 1 and up 3, right 2 and up 1.5. You know this is a curved shape, which is why 2 dots are enough. It can't be linear in nature because then it would cross the invisible wall, and you're not allowed to do that. So we're going to go up and get really close to that vertical asymptote there. If you have an x on the bottom and just a regular number up top, then, of course, the x-axis serves as a horizontal asymptote, because think about it. Even if I plugged 3 million in for x, 3 over 3 million would reduce to 1/1,000,000th. So I'd go right 3 million and up 1/1,000,000th. Okay, pretty obvious this is going to progress and get close to the x-axis and be a curve in quadrant 1. Now, going back to our library, remember the one we had was 1 over x that we sketched? He should have a twin brother probably in what? Quadrant 3, right? Well, to check for sure, just plug in 2 numbers to the left of the asymptote. See what's happening on that side. So we could quickly plug in negative 1 and negative 2, and wouldn't that just create negative 3 and negative 1.5 for our 2 answers? So, just like we thought, left 1 down 3, left 2 down 1.5. I can connect those up and look like that. Okay? Now careful, over here on number 2, if I make a table, don't plug 0 in first. I didn't say plug 0 in first. I said plug in whatever number makes the denominator turn into a 0. So if you look at this problem, wouldn't that number be negative 1? because -1 plus 1 gives you 0, right? So I've got a 0 on the bottom, making that point undefined, meaning I'm still going to draw a vertical asymptote, but it's going to be at -1 this time. And to see what's happening to the right or the left, right, just pick two numbers to the right, which would be what? 0 and 1, and plug those in. If I plug in 0, 0 plus 1 is 1, -2 over 1, you agree, is -2. Plug 1 in for x, 1 plus 1 is 2, -2 over 2 is -1. So I've got a dot on -2, and then right 1 and down 1. You can see it's getting closer and closer again to the vertical asymptote. It can never ever cross it. Closer to the x-axis there. So I'm assuming his twin brother is going to be what? Up in this section or area over here because of our library, our mental image of what we know about these, to check and see for sure what's happening to the left of the asymptote. Careful, what two numbers to the left would you pick? You'd pick -2 and -3. Agreed? -2 plus 1 is -1. -2 over -1 gives you 2. -3 plus 1 is -2. -2 over -2 is 1. So we're going to go left 2 and up 2, left 3 and up 1. And we indeed have the reciprocated mirror image of that guy down there. Okay? Quick sketches, no big deal. Looks like that. Third block says y equals 2 over x squared. I'm going to make a table. Again, my instinct is what? It's a reciprocal function. There's an x on the bottom, creating a vertical asymptote. This time, again, it would be at 0, because 0 squared 0, and that's still undefined. Draw my vertical asymptote through 0. Pick two numbers to the right. I'm going to pick 1 and 2. 1 squared, careful, is 1. 2 over 1 is 2. 2 squared is 4. 2 over 4 gives me a half. Agreed? Big deal. Easy math to do. So plotting my points, right 1 up 2, right 2 up a half. The same thing is happening that we just saw on the ones up above, but careful. Think back to your library of functions. What's the difference between just an x on the bottom and now an x squared on bottom? I believe his twin brother is going to stay above the x-axis instead of down in quadrant 3. Agreed? Because think about it. To the left of the asymptote, we would plug in -1 and -2. -1 squared, guys, remember when you square a negative, you still get a positive, would be 1. So that still creates a 2. And -2 squared creates +4 and 2/4. Oh, I generate the same two y values. So I'm going to go left 1 up 2, left 2 up a half. I connect them up. Looks like this. And oh my gosh, both curves, they're twin brothers, but they're both elevated above the x-axis, okay? Calculus-wise, couldn't you spin that around the axis of symmetry? If I said spin this function around the y-axis, now you don't have to do this on your paper, guys, but if I spin this around, wouldn't it end up looking something like that? Oh my gosh. Could be a volcano, a tree trunk, a test tube. What would the volume of that test tube or that tree trunk be? We could figure out the volume by integrating again in calculus next year. Oh, and we would integrate that function. Well, all that calculus type stuff isn't going to make sense and turn out okay if you can't quickly sketch that function like you're supposed to be able to by hand. Okay? Finally, our grand finale. Oh boy. -1 over x squared minus 4. I'm going to make a table. Okay, freeze. When I ask you what number could you plug into this function that turns the denominator into a 0, I think we'd all say 2. correct? Because 2 squared is 4, minus 4 gives me 0 on the bottom, and that's undefined. However, wouldn't negative 2 also create a 0 on the bottom? Because negative 2 squared, right, is also positive 4. Minus 4 gives me a 0, and it's also undefined. So the obvious point is, careful, I've got an asymptote at 2, but I've also got an asymptote at negative 2. Wow. This poor guy's got 2 asymptotes. So what do you got to do picture-wise? Wouldn't you have to pick a couple numbers to the right, a couple numbers way over here to the left, but also a couple numbers in between? It's like those 2 invisible walls are divided into 3 sections, my picture. You can't ignore one of those and pretend they don't exist. So unfortunately for us, give me 2 numbers to the right of this asymptote. Wouldn't we pick 3 and 4? Let's plug those in. Plug 3 in. 3 squared is what? 9. Minus 4 is 5. So I would have negative 1/5. And when I plug 4 in, 4 squared is what? 16 minus 4 is 12. Creating what? Negative 1/12. So over here to the right of the asymptote, I'm going to go right 3, down 1/5. That's not very far. Right 4 and down 1/12. So what's happening is I'm going along the x-axis, hitting that, and eventually taking a sharp turn upward and getting close to my vertical asymptote. Now think about it. If I go way over to the left of the other asymptote and pick the numbers negative 3 and negative 4, wouldn't that produce the same 2 answers that 3 and 4 did? Because all I'm doing is squaring them and creating a positive value anyway. So we already know this is also negative 1/5 and negative 1/12. All right, hopefully you can see those, but I just said what they were, so you're fine. So I'm going to go left 3, down 1/5, left 4, down 1/12. And I do create the mirror image of that other curve that we drew. So now the question becomes, man, I got to extend this even further. What's happening in between the 2 imaginary lines? Wouldn't we pick negative 1, 0, and 1 for 3 points in between there to get an idea of a picture? You got to sketch it as accurately as you can. Obviously, if I take negative 1 or 1 and square it, I get 1. 1 minus 4 is negative 3, and negative 1 over negative 3 is positive 1/3. So I'm going to go left 1, up 1/3, right 1, up 1/3. When I plug 0 in, 0 squared is 0, minus 4 is negative 4, negative 1 over negative 4. I know you're not going to be able to see this, but we're putting a 1/4 in there. So 1/4 is not quite as tall as 1/3, agreed? So if I go up 1/4 and connect these up, we end up with a smiley face, who would have thunk it, in between those 2 vertical asymptotes. So sketching reciprocal functions takes a little more time than some of the things we've done so far, but logically, your mental approach, that should make sense to sketch a quick, accurate picture. Okay? All right, that concludes Thursday the 14th. Homework or your assignment, which is going to be due tomorrow on Friday the 15th by noon. Hopefully you're watching this and taking your notes on the 14th like you're supposed to. You might as well get to this point and do this assignment while this is fresh in your mind and turn this in as quick as you can. Why wait till Friday morning? But that's your call. Your 4 homework problems are as follows. You can see them here on the paper, so hit pause at this point. We've got negative 1 over x, 3 over x minus 2, negative 2 over x squared, and 2 over x squared minus 9. If you get stuck on a step, And man, where do I go from here? Certainly look at the notes you just took. They're there as a learning tool. These problems, of course, just mimic what I just did, and you should be fine. All right? All right, tomorrow's Friday the 15th. I will see you then. Great job.